In this video, we are going to talk about confidence and accuracy, how they relate to each other, and then we are going to work an example from our book. Okay, so confidence, we're talking about the confidence level. Accuracy, right, is basically the width of the confidence interval, right? And so the smaller the confidence interval is, the more accurate our estimate is, right? And the bigger the interval is, the less accurate it is. It gives a wider range of possibilities, okay? All right, so the relationship between those two is that for a fixed sample size, if you decrease the confidence level, that's going to decrease the margin of error, okay? So in other words, if I have a 99% confidence interval, right, and then I make another confidence interval that is 90% confidence interval, right, that is going to decrease the margin of error. I'm going to get a smaller interval, okay? And so with the smaller margin of error, that improves the accuracy of a confidence interval estimate, okay? So decreasing the confidence level improves the accuracy, all right? So, but it also, right, makes you less confident. So it's sort of a trade-off there, right? You have to give up some confidence if you want a more accurate answer. And if you want to raise the confidence level, well, then you're going to give up something in accuracy, right? So again, it's kind of a trade-off. You have to decide, you know, when you're doing these kinds of things, what it is that you're after, okay? All right, or what you're willing to put up with. Okay, so let's take a look at an example that illustrates this. This example is 8.78 from our book. It says American alligators multi-sensor data loggers were attached to free-ranging American alligators in a study conducted by Y. Watanabe for the article Behavior of American Alligators Monitored by Multi-Sensor Data Loggers in Aquatic Biology. The mean duration for a sample of 68 dives was 338 seconds. Assume the population standard deviation is 100 seconds. All right, and we want to find a 95% confidence interval for the mean duration mu of an American alligator dive. All right, let me make sure that looks okay. Nope. All right, that looks better. Okay, so the sample mean was 68. Oh, nope, sorry. 338. All right, sample consisted of 68 dives, so n equals 68. Population standard deviation was 100 seconds. All right, and we want a 95% confidence level. All right, so 338, 68, and 100, and 95. Okay, so part A, we want our confidence level, our confidence interval rather, right? So we know that the lower limit is going to be x bar minus z of alpha over 2 times sigma divided by square root n. And the upper limit is going to be x bar plus z of alpha over 2 times sigma over square root n. All right, so let's calculate all that out. So x bar is 338. Z of alpha over 2. So our confidence level is 95%. So going back to our chart over here, right, we see that that corresponds to a z of alpha over 2 of 1.96. All right, sigma is 100, and our sample size is 68. Okay, and the upper limit would be same thing except with a plus. Like so. Okay, so let's go calculate that out. So that is 338 minus 1.96 times 100 divided by the square root of 68. Okay, so that's 314.23. And the one for plus, right, is going to be 361.77. So let me write those down. 314.23 to 361.77. Let me just double check that. Okay, looks good. All right, so there's our confidence interval. All right, it says repeat part A at a 99% confidence level. Okay. So for a 99% confidence level, I'm going to mark this one as the 95% one here. And so everything is going to be basically exactly the same. Right, for the 99%, right, the x bar is still going to be 338, sigma is still going to be 100, the sample size is still going to be 68. The only thing that changed is the confidence levels. It's now 99%, right? So going back to our table, we see that it would be 2.575, the value of z of alpha over 2 for a 99% confidence level. So really that's the only thing that's going to change on these calculations here, okay? So 2.575. And same thing on the upper limit for the 99%. Okay. All right, so that's what we get for part B. So our confidence interval for part B is going to be 306.77 to 369.23. Okay. And that's our 99% confidence interval. All right, and so what you can see is here we raised the confidence level up, right? So we have a higher confidence level, but you can see that it gives you a wider interval, right? This number 306 is less than 314, 369 is bigger than 361. Right, so our confidence level increased, right, but then the accuracy decreased, right, from here to here, because this, right, is going to be a wider interval, so it gives us a bigger range of numbers, so therefore it's going to be less accurate than this confidence interval. Likewise, you can look at it this way, right, if you go from a 99% confidence level to a 95% confidence level, so you're dropping in confidence, that's going to increase, right, your accuracy. here. You're going to get a smaller confidence interval. All right, so going back to the problem, it says, draw a graph similar to 8.6 in page 343 to display both confidence intervals. I'm just going to use Desmos to do that. You don't have to do that. It's just illustrating what I just told you about the relationship between confidence and accuracy. So I am going to just draw this, and we'll need to go basically from like 300 to 400, let's say, on the x-axis. All right, and these little things up here I'm just using to draw the confidence intervals. So you don't have to really worry about what these are. So the first one's going to go to 314.23 to 361.77. So that was our 95. The purple confidence interval is here. So what we're saying is about we're 95% confident that the population mean is somewhere right in this range of numbers. I just drew it above the x-axis so it's a little easier to see it. Okay. All right, I'm going to do the same thing with the 96 or the 99% confidence interval. So that's 306.77. And that goes all the way to 369. .23. Okay. So you can see that's the black interval right here. And again, I just drew it above the x-axis to illustrate, to make it a little bit easier to look at, so you can see where it extends off to. All right, and so again, that's illustrates the point that we just talked about. When you decrease, right, the confidence level, we're 99% sure, right, that the mean, population mean, is somewhere right within the bounds of the black confidence interval here. That's our 99% level. So then when we drop the confidence level to 95, right, we get a more accurate estimate, right, because it's smaller. There's less possibilities right now, and although we're only now 95% sure that the mean, right, the population mean lies in the purple interval here. Okay, so that illustrates the trade-off between confidence level and accuracy. All right, it says which confidence interval yields a more accurate estimate of the population mean mu, right? And that's exactly what we were just talking about. The purple one, the 95%. It's smaller, right? It has covers less width or less length right here. So it is more accurate, although we're not as confident, right, in that the population mean is in there, right? We give some of that up to get a more accurate estimate. So again, it's a trade-off as to, which one you want. All right, and I think that's it for this example.